Right. So we've seen how to determine or predict the charges on these monoatomic ions, how to put them together to make ionic compounds and how we name them. We're going to add one layer to this ionic compound and ionic bonding section. And that has to do with the fact that when we look at ionic compounds, often what we are going to encounter are not just these monoatomic ions, but we're going to encounter ions that are a little bit different called polyatomic ions. And these polyatomic ions, as the name maybe suggests to you, is that these are ions, so they're going to have positive or negative charges, just like every ion will. Okay, but these are different than monoatomic, which we've looked at before. So the monoatomic ones were the ones that were just for a single atom that had a charge. Okay, these are instead polyatomic. So what this means is these are collections of atoms or groups of atoms that have an overall charge. Okay, and there are several of these that we're going to see that you're going to encounter. There's a long list of them, but we're going to whittle that list down to the most important ones or the most common ones that we're going to see. So you need to know, and this is something you're going to have to memorize, you need to know the list that we're going to provide of polyatomic ions. So that means you need to know the names of the ions, the formulas, and then their charges, very important. So let's take a look at the first few of these. The first one, and there's actually very few polyatomic cations, but there is one that is really, really common, and that is the NH4 with a positive or a 1 plus charge. Okay, and this is called ammonium. That's the ammonium ion. Okay, so what this means is the N and the 4 H's together have an overall charge of 1 plus. Remember, when you have a 1 plus charge, you can just write 1 plus, or you can just write the plus. The one is understood to be there. Okay, so this is a polyatomic cation. The vast majority of the polyatomic ions tend to be anions. So let's take a look at the most common ones. We have OH with a 1 minus charge. This is called hydroxide. We have CO subscript 3 with a 2 minus charge. This is called carbonate. We have H, we stick an H in front of the CO3, then we end up with a 1 minus charge. This is called hydrogen carbonate. Or a common name for this is bicarbonate, something you may have heard about before. There is another polyatomic ion, NO3, with a 1 minus charge. This is called nitrate. There is an SO4 with a 2 minus charge. This is called sulfate. And then we have PO4, the 3 minus charge. This is called phosphate. Okay, so we've seen 1, 2, 3, 4, 5, 6, 7 of these polyatomic ions. And I think that's as much as those are the most common ones. Actually, add one more on here, maybe the most complicated one. This is C2H3O2. This has 3 different types of atoms, and this has a 1 minus charge. This is called acetate. All right, so all of these 1, 2, 3, 4, 5, 6, 7, these 8 polyatomic ions, you need to know these names, formulas, and their charges. So how do we how do we incorporate these into ionic bonding, ionic nomenclature? Well, we're going to treat them the same way like we did previously. So let's take a look at a couple examples, right? So we want the name and the formula for the following. We're going to combine magnesium and let's do the acetate. Okay, so magnesium, we know it's one of the monoatomic ions. It's Mg. It's in group 2. It's a metal, so it's 2 plus. And then acetate, now you need to know what acetate is. So it's C2H3O2 with a 1 minus charge, right? So we have our ions, just like we did previously. The only difference now is these polyatomic ions, you have to memorize them, however you do that. How we combine them is going to be the same method. We can do our crisscross. So we write the cation first. So we have Mg, and then we have our polyatomic anion. So it's C2H3O2. And then we can do our crisscross method, right? So the 1 here becomes a subscript on the magnesium. And now, if you think about, well, if we do the crisscross with the 2 here on the magnesium, where am I going to put it? Right? Where does that 2 go? If I put it here, then it says C2H3O22, and that really doesn't make a whole lot of sense. What you're trying to represent here is the fact that you need 2 of the acetates, right? So how do we write that? Well, this is where the use of parentheses is going to be important. So if you have more than one of a polyatomic ion in your formula, you need to put it in parentheses, and then you put the subscript on the outside of the parentheses, right? So this is telling me I need 2 acetates for every 1 magnesium, and I clean up my structure or my formula. I can get rid of the 1, so it's Mg and then C2H3O2 twice. And that's this extra layer, right? So we have the polyatomics. When you see them in a formula and you have more than one of them in the formula, you need to put them in parentheses. That's the only way that we can accurately depict the ratio. All right, let's take a look at another one. We'll do aluminum. Actually, let's do ammonium. And we will do phosphate. We didn't actually finish that question above because in addition to coming up with the formula, all right, we also have to name it. So we're going to name it the same way we did the previous ones. So the cation goes first, so it's magnesium would be the first name for this. And then if you have a polyatomic ion, you just name the ion as it is. So that you have to recognize as acetate. So we're going to name it as magnesium acetate. And that's it. All right, so the next one, we have ammonium and phosphate. So ammonium is the NH subscript 4 with a 1 plus charge. That's the ammonium ion. And then phosphate, another polyatomic, would be PO4, and this has a 3 minus charge associated with it. So when I combine these two now, you can see now I actually have 2 polyatomic ions in my formula, right? I'm going to write them just like we did before. So you always put the cation first, so NH4, and then I have my anion second, PO4. And what I would suggest that you do is just go ahead and put these in parentheses at the beginning. And then if you don't need the parentheses later on, then you can get rid of it. But this allows you to visually look at your combination and your eyes are telling you, well, you know what? The NH4 comes together, right? That's a group, that's a collection. The PO4 is a collection as well. So I'm going to treat them as entities. And then I can do my cross-charge thing, my crisscross, and I can put the subscripts in the correct location. So the 1 here on the ammonium goes on the outside of the phosphate, and then the 3 on the phosphate goes on the outside of the ammonium. So I end up with NH4 3 times. So I need the parentheses, definitely. But now I only have 1 of the phosphate, and when you only have 1 of the polyatomic, then you can get rid of the parentheses. So it just becomes NH4 3 times, and then PO4 without your parentheses, right? That's your final formula. And when you name it just like you write it. So cation name first, that's ammonium. We don't change that name. And then the polyatomic ion, we, again, don't change that either. So PO4 is just the phosphate. So ammonium phosphate would be the name for this combination that we have. All right. So these polyatomic ions, very, very, very common. You see them all over the place. They're actually way more common than the monoatomic ones we saw previously. Let's do one more. If I combine sodium and hydrogen carbonate. Okay, so sodium is the Na. It's in group 1 and it's a metal, so it's 1 plus. And then you need to know the hydrogen carbonate is the HCO3 with a 1 minus charge. All right, so when I combine these two, put the metal first, I have a polyatomic. I'm going to stick that in parentheses, HCO3, and I can do my cross charge. Okay, so the 1 here becomes a subscript on the sodium. The 1 in the sodium becomes a subscript on the car. So I have 1 of everything, right? I can go ahead and remove my parentheses now. I can remove the 1s because the 1s are understood. So I end up with NaHCO3. And if I name it, right, so I have my sodium, my metal, and then my anion here. The last thing would be hydrogen carbonate. So sodium, hydrogen carbonate, or we saw that there was another name for hydrogen carbonate, which was bicarbonate. So sodium bicarbonate, or another name, a common name for this substance you probably know or use frequently. This is also called baking soda. All right, so baking soda you have in the fridge or used for baking, I guess, is nothing more than an ionic compound composed of sodium ion, and the bicarbonate or the hydrogen carbonate ion, which is a polyatomic ion. So, all of us have this. Most of us have these in our kitchens or other places. And it's very, very common, right? So these things are you find all over the place. Now, hopefully what you're getting from all of this is that, these formulas that you see or these names that you see, for example, in, the labels on the stuff that you eat or drink or use at home for cleaning and all that stuff, they all represent compounds, right? Either ionic compounds, as we've been talking about here, or maybe in the next section, we'll talk about covalent compounds. You can come up with the formulas for those things. You can identify what atoms and ions make up those substances. So here we have, I just pulled this label from a toothpaste box, and it kind of shows you where you would see some of these compounds, ionic compounds, or maybe other types of compounds as well. So here, if you look, and again, you can check your own toothpaste at home to find these things. So for example, the active ingredients in your toothpastes are usually some sort of fluoride that helps prevent cavities. So in this case, it's sodium fluoride, right? And sodium fluoride, you can actually come up with the chemical formula for that. Well, it's got sodium in it. We know sodium is in group 1, so it's 1 plus. Fluoride comes from fluorine, which is in group 7, so it's going to have a 1 minus charge. Put these together, we end up with NaF, right? Very similar to sodium chloride, which is NaCl. So this is, what you find in your toothpaste. If you look at some of the other ingredients down at the bottom, so it says inactive ingredients, these don't actually cause any, health improvements or improve your health like the sodium fluoride does. But other things on here too may sound familiar. So for instance, we talked about sodium bicarbonate baking soda, and there it is. It's an ingredient, an inactive ingredient in this particular brand of toothpaste. I don't know what this is, minty, that thing. But it is present. There are other inactive ingredients here as well that serve a variety of functions, but the point here is you find these ionic compounds in lots of places. In the most mundane things like your toothpaste, you can easily find them. as ingredients.